Okay, PF1 video 3. So we just took a look at the old little Unix file system assignment where you guys drew a little picture then. And to be clear, I mentioned this before class, but there's a few students that will be watching this from home, I guess then. So that little picture that you drew, it's a first part of a two-part assignment that will be graded Monday morning when we come to class. We're going to actually grade that in class, and it will be for a grade then. But if by chance that your little Unix file system picture was incomplete or not done or whatever today, due to difficulties of connectivity and all the rest with the snow day and trying to iron out all those kind of things, fear not. That's kind of okay. This is really the one lab, I guess, this semester where late work will be accepted just because it's actually not for a grade. So don't worry about that, but make sure and kind of get that done if necessary. Review that video that I posted on Blackboard on how to navigate the file system and so on. And I guess you guys are starting to feel pretty comfortable with that because looking around the classroom, lots of very good jobs on that then. And one thing I don't remember for sure, now right before class, one thing I did is I happened to, every once in a while I'll remember, just for the last few years, sometimes I'll remember at the end of the semester to make a copy of that semester's lecture notes to a different area here in my little home directory here on this PC. And it was kind of handy today then because, well, the lecture notes that I have here, they were incomplete because they didn't get updated on Monday compared to yours, which you updated from home. So I just went and copied some things into place. And I think now that my little summary of Unix commands here now should be kind of caught up with yours. Uptime, did I mention in that video the stability of the Unix operating system and how long it can stay up and so on, talking about the uptime command? And did I mention that what happened just recently, it was at the end of the summer, I had the system had been up, no lie, for 3 years and 8 months without a reboot. Boy, you talk about stability of an operating system. What's the record longest time that your home PC has ever been up without a reboot? Microsoft is going to sneak in a reboot one way or the other, every week or two or something like that, But with Unix and Linux, those things are rock solid, kind of depending on how you administer them and so on. They can run for a good long time. And I had that darn system up for 3 years and 8 months. It was 1,300 days, something like that. And then one of the other administrators went into the closet down the hall where those servers remained to work on a system, and he was going to power it off. And oops, he powered off the wrong machine, powered off mine. And so there goes that record. But even at that, that happened at the end of the summer. And here we are. Well, now it's the beginning of the spring. So even at that, well, that was 161 days, however many months ago that was, something like that. What is that going to be, 5 or 6 months ago, something like that. So the old Unix, in this case Linux systems, they are just rock solid. And anyway, so there's that. So the uptime command, you covered that. Certainly you had to with the discussion of current working directory and home directory and relative path and full path and all of that. I'm sure we've covered the pwd command, the ls command, and the cd command, and also makedir. And oh yeah, speaking of makedir, one other thing here, I'll just go ahead and it might be helpful. I'll go to the trouble here real quick and pull up my little drawing tablet. All right, so there's that. And we'll get rid of that and zoom in. Okay. And so I think as part of the video then that I assigned for Monday, I think it was the case that under your home directory, all right, so here's our little symbol for our home directory. That's a special symbol to bash. I think we should have covered that last week then also, or last lesson, excuse me. And then I think it was the case, did y'all do this? I think you did. Practicing working with relative paths going down. And then we discovered, the ... directory, our good friend, that also can be used to go back up. And so we made this tiny little directory tree here underneath our home directory just as part of last class period's lesson. And well, now this tiny little directory tree is going to sit there from now until doomsday, I guess, till you graduate, just because we created it. Hey, how about getting rid of that darn thing? That might be a good idea. And so let me show you another command then related to that. So hey, we learned the makedir command. How about the rmdir command? Rmdir. All right, to remove a directory. All right, I'll say, gosh, details. Yeah, I don't hardly need to give you any details. Oh, what the heck, we will. Details on vid3. Okay, so I'll go down. Let me start a vid3 section of our notes in here for today. Vid3. Okay. So the usage, kind of a weird word, but anyway, that's the computer term that is often used. Usage information tells you how to use a command, for instance. So, all right, usage for the rmdir command. All right, so it is going to be rmdir, and then you have to supply a directory, a path to a directory. Dir path will say as such. And actually, and I'm trying to remember, hopefully it was the case, I don't remember. Did y'all learn about the square brackets and the dots? Okay, very, very good. And what they tell you then when you're looking at the syntax for a command and so on. So this says that you can repeat this previous thing, in this case, a path to a directory. You can remove multiple directories at once. So rmdir is kind of your friend. And so tell you what I'm going to do here real quick just to catch up with you guys. So I'm going to say make dir A, and I could say cd to A, and then make dir B, you know, in order to get this picture over here. You know, I could go ahead and cd to directory A and then do a make dir B and so on. That's probably what I did in class in the video. But I'm just going to, for the heck of it, go and say make dir A/B. So that's a relative path. So my current directory, again, if you're using a relative path, you have got to know, either in your mind, and perhaps on paper also could be helpful, my current directory is right here. And since my current directory is here, if I specify A/B, well, I'm going to start searching for that thing at A, and then anyway, I'm going to create B down inside of A. And anyway, that worked without complaint, and sure enough, it did create directory B. And now make dir A/B, slash. Hey, there we go. So now I'm kind of caught up with you guys. And now we've learned the wonderful rmdir command. Rmdir A. Well, we got a little problem here. By default, rmdir only wants to remove empty directories. Only wants to remove empty directories. So how do we work around that? And well, for today, we're going to work around it. You know, now, to be clear, you're probably wondering, you mean to tell me that Unix doesn't have a command that you can use to remove a directory and all of its contents? Of course it does. I'm not going to show you that command just yet. Okay, just yet. We'll hold off just a tiny bit. It's kind of silly, but again, one thing about Unix and Linux is the creators of it, of course, they're all brilliant, they're all gurus and so on, and they were writing that operating system for themselves, so that they could get a lot accomplished with a small amount of effort and so on. So that Unix literally was written for gurus. And they didn't want to be bothered with a bunch of annoying confirmations and those kind of things, you know. So if you copy a file on top of another file, you know, Windows is going to pop up, hey, this file already exists. A little message box will pop up. Do you want to override or not? You know, and you get a chance to catch that. If on the other hand, in Unix, if you say copy this file over to here, and there already was a file with that same name in that desired location, guess what? It overwrites the doggone thing, and there is no checking, and there's no recovering what just got overwritten. And similarly, if you remove something, it's not going to confirm or whatever, it's going to remove the darn thing. So it's not going to bother you with annoying confirmations. So it can be good for the guru, but there's some opportunities for oopses for newbies, I guess, you know. So yes, Unix does have a command that you can use to remove a directory and all of its contents. But we're going to hold off just a bit because I have seen over the many years, not often, but often enough for new users to accidentally remove, and the permissions will allow you to do this. You can't cause harm to other users and to the system as a whole, but you can, with an errant remove command, you can accidentally remove your home directory and all of its contents. And once that happens, you can't recreate it, because to recreate it, you have to write in the parent directory, which is home, and you don't have write permission to home, for instance. So anyway, it's possible you can accidentally remove your entire directory, home directory. And so we'll hold off just a bit to show you the more powerful command. And if nothing else, it's just a good little lesson here and practice navigating the system. So if I can't remove A because it's not empty, well, B's not empty either. Oh, but C is. Okay, so in order to do this, we're going to need to get rid of directory C. And of course, you know, the most logical thing for a new user would be cd A/B. All right, no, so A/B, no leading slash there, cd A/B. so that your current working directory is in directory B. PWD to verify where I am, ls-l. You guys did plenty of that over the last few days then. Okay, sure enough. So I am in A/B here under my home directory, and looking there I do have a directory, see over here, D for directory, called C. So now I can say rmdir C. All right. And I'm still in directory B, and can I remove the directory that I'm in? No, I can't. So cd to .. And how about rm, or they'll verify where I am, and ls-l. Okay, -l. I guess I should update my picture. Yeah, I'll do that real quick just for grins. All right, so I got rid of C, zap, it's gone. And now I'm up into directory A, and I take a look, and there's directory B there, so rmdir B. All right, so it's gone. cd to .. cd to .. pwd to verify where I am, and then we'll get rid of A then also. All right, so there's that. I'm in my home directory, ls-l. Of course, I got lots of stuff here, rmdir A. All right, so there's that, just as the introduction to the rmdir command. Remind me at some point in the future, and we will show you a more powerful command that will allow you to get rid of an entire directory tree and everything under it. And oh yes, so speaking of things to remember to talk about, there is one other thing I wanted to talk about. It's kind of aggravating for me. You know, I try to provide these video lectures for students that have to miss class or whatever, or need to review the material. And so every once in a while a student will come up right after I stop the video at the end of class and ask an excellent question. And yeah, I could join them together. The tools that I have to do so, they take a bit of time, and also the file gets much bigger and so on when I use the tools to do that. And so as often as not, I just defer till next time. And one good question that we had come up at the end of class on Wednesday last was, how can I connect in with a Mac, or for instance, from one Unix system to another, something like that. And here's the short version of that. So if you're on a Mac, you'll browse and search and find the little program called Terminal. So your Macintosh will have a program called Terminal, and you'll run it. And when you do so, well, you get something similar to this. So you saw this before last Wednesday then, and so this is our command prompt in Windows. So here I'm executing commands on my Windows PC that I'm standing in front of here then. And but if I wanted to log into our server, I could use PuTTY, of course, you know, on my Windows PC, but I also have the option of logging in with a command called SSH. It popped up with Windows 10, and it's kind of nice. So SSH is the protocol that we're using to connect. This is a program called SSH, conveniently named, because SSH is the protocol that we're using to log in across the network and connect into port 22 on the server and send our commands back and forth and so on. But anyway, so we run this program SSH, and then you have to tell it where to log in, what system, and also what username you want. So in my case, my username is such at cs.actx.edu. Boy, doesn't that look like an email address? They conveniently, you know, made this. There's another syntax you can use, but I like this one here. It looks very much like an email because you have your username at, and then the host name, including the domain name and so on, and that works just great. So when you hit enter, all right, it's going to ask for your password. Oops, I might have fat fingered that. I don't know if that's going to work or not. It didn't, but anyway, I'm logged in there. I'm logging in there. Oh, what the heck? I'll see if I can get it the second time. When the pressure's on, it's hard to type your password. Hey, there we go. So I logged in not using PuTTY. So now I'm on my Windows PC, and I logged in not using PuTTY. But anyway, if you were on a Mac, you'll do the same thing. But instead of going down to the bottom and typing CMD and searching for that particular program, you'll search for that program called Terminal. All right, so exit. You know, that said, one other thing I want to mention about that. So if you want to bring your Mac to class, MacBook, whatever, and work, that's perfectly fine. But I do want to remind you, and also other students, you know, with PuTTY, you can have, I didn't bother to show you, but you can go ahead as part of your session. Remember we showed you a week ago that with your session you can save the font and the color and the host name and those kind of things. You can also have it save your username and your password. And then you just double click on your session and poof, it just logs you in. But there's a downside to that. I kind of would almost recommend that you don't have it save the username and password. Security issues, of course. I mean, I'm not too concerned about little brother sneaking in and logging into your account and removing all your homework or whatever, so that's probably not too big of a deal. But one other little thing that does pop up regularly, you have to hold off here, is that on test day, I'll have students and they need to come in and log in, and they have been working from a Mac or something else from home, and they've got it set up where it automatically supplies their username and password, and they'll forget their username and their password. Okay, so I'd encourage, and you certainly don't want to have it here on your system here, because I think it's the case, if I remember correctly, that where the sessions are saved, your session is visible to other users on the system you're sitting on in this classroom. So anyway, I'd kind of encourage you, go ahead and type in that username and password just to make sure that you can. And again, if you bring a Mac to class, that's fine. But on test day, you can't use the Mac. You're going to have to use the Windows PC that you're sitting in front of then, okay? So make sure you know how to use PuTTY. Make sure you know how to use PuTTY. All right, so there's that. Other little housekeeping things. Nope, got it. I think we're good. All right. So at the bottom of your picture that you drew, over on the far right-hand side, and that was kind of the trickiest, I guess, part of the that little file system picture, is you had all of those subdirectories with the same name, which is perfectly fine. We learned a rule that one directory can't have two children of the same name, but a directory can have a child and a grandchild and a great-grandchild, with the same name then also. That's because anyway, that's clear. There's no problems there. But every once in a while, students will I don't know, think they're stuck in a loop or something else like that and give up before they get down to what was that bottom directory called? The dungeon. Yeah, the dungeon. And down in the dungeon, you had a file, a secret file. And I don't know if y'all were aggravated or not, there's a secret file. And I don't think that I had given you the command to use to display the contents of a file. So that's kind of aggravating. You found that there was a file. It's a secret file. And if you happen to look at the number of bytes, with the ls minus l shows the number of bytes and the modification time and that kind of stuff and so on, So like right here, for instance. Actually, this is a directory, but anyway, I got nothing but directories in my home directory. But anyway, this here would be the size. And directories have a size then also for what it's worth. So why don't we start off the day also then by showing you the command that you can use to display the contents of a file. So we would say that you use the ls command to display the contents of a directory, right? To examine the contents of a directory, we use ls or ls minus l. But all right, back to our notes here then. To display the contents of a file, all right. We'll just stick here kind of in the same way. Cat to display the contents of a file. And is there some usage information on that available or necessary? Probably not, to be honest. It's pretty simple little command. I need to tell you what, I'm going to do this real quick. Hang on one sec. Let's go here, and no, maybe not here. I think it's here. And quit putting in, well, I don't see it doing extra spacing here. Don't add extra space. Okay, maybe that's what I needed to do. Okay, we'll see if that works better then. All right, so cat. And, well, what the heck, we'll go down to the bottom and do the same thing, I guess. Details such as they are on vid3. Okay, fine. So down here, usage for rmdir, usage for cat command. And same kind of thing here, cat, and it's going to be a file path. And once again, you can actually have it cat one file, then another file, then another file, and they just all get appended together. So the question might be, you're thinking, good grief, what were those old hippies smoking when they decided to come up with a command called cat? I don't think it's cat as in a feline animal, a kitty cat. I think it is. So in fact, we might have some students that have done a little programming before. But in programming, and if you're working with strings, well, you can take one string and another string and you can append them together. So for instance, you can take your first name and your last name, and if you stick them together, then that's your full name. So anyway, in programming, if we're taking two strings and putting them together, one term that is often used to describe that process is called, does anybody know? Did I hear? Nope, thought I heard something mumble. Well, in programming, we might refer to that as to concatenate. Concatenate, kind of exactly like it's spelled, concatenate. I'll just type it over here just as an FYI. Concatenate means to append one string to the end of another string. And again, all those old guys, and well, this old guy also, I guess, are all kind of lazy, and hey, if we can come up with a shorter version of that, then all the better. So concatenate is often abbreviated catenate. And I believe it's the case. I've never actually looked to see and maybe track down, read the history of the cat command. But my guess is cat is short for catenate, which is short for concatenate. Because with cat, what you are doing is you are appending the contents of a file to our display, if you will. Appending, does that make sense? We're displaying it on our terminal, but I'm going to call that appending. Well, think about this again. All right, back to, once again, a lot of things get explained away by looking at this picture of these old guys here. So back in the day here when Ken and Dennis were working on this paper console, and all right, so every command they typed and all of the output for every command they typed got printed out on this continuous fanfold paper that was coming out the top of this paper console, it was called. Anyway, so oh yeah, so if I take and display a file, it prints out, it gets appended to that piece of paper. And if I cat another file, it's going to print out and get appended to the end of that piece of paper. So if you're appending data to a screen or to a paper console here, you are concatenating then. So I think that's where cat comes from. Kind of goofy then. All right, so I'll just mention that. There you go. You can display the contents of a file with the cat command just by typing cat and then a path to a file, and more than one file if you want. Okay, so that's right. We worked with the message of the day file or the host file or anything else like that. Did we do any of that on Monday's lecture? I don't think that we did. We might today, and if I remember, we'll cat those. In fact, let's just do that real quick. So just as a piece of trivia, I guess, all Unix and Linux systems, they store configuration information just in files. And oh, that's right, we did mention that when we covered the file system tree. We drew the picture with the etc directory and the temp directory and the bin directory and the home directory and so on. Part of what we did in the video for last class period covered that. And anyway, so the etc directory contains configuration files. And that's one thing I really like about Unix and Linux is information on users and groups and passwords and printers and web servers and a whole bunch of things. The information for those programs is just stored in a regular old text file. And you can just look at it with a text editor. You can make modifications to it and so on. It's very, very open and accessible and easy to get to and so on. Once you know what the file is, you can just jump in there and dive in. And I kind of like that as an alternative to, so in Windows, where's the top secret, configuration information stored in Windows? Many students don't know that, don't really know anymore these days, because for the most part, and that's good, you don't have to know, because for the most part, Windows just runs, and you're not having to Google and figure out how to fix this problem and dive into various tools and so on, trying to make things work and so on. But have y'all heard of the registry on Windows? The registry. It's kind of a database, if you will, that's stored in some top secret location, and you can't just go there with a text editor and examine it and make changes to it or whatever. Instead, you have to use these special tools called registry editors. All right, and if you ever do any Googling or reading about editing or making modifications to your registry, it's going to tell you be very careful. Be very, very careful when you're modifying the registry, because if you mess up somehow and you corrupt the darn thing, basically the system is just toast at that point, because everything is stored in the registry, and again, it's a file you have to use these special tools to examine and so on. Anyway, in contrast to that, Unix just stores all this configuration information just in regular old text files that you can examine with a text editor and so on. So one of those, for instance, like, check this out. I'm going to cat a file in the etc directory, so I'm going to use a full path there. etc motd. What that stands for is message of the day. This is just trivia. It's not really anything you have to worry about. But message of the day. Message of the day, what is that? Well, the administrator, me, I can go in and I can edit this file, the message of the day file, and I can put notices that I want my students to read the next time they log into the server. You guys are going to recognize this. See, when I cat this file, look what happens. Oh, see, here's the file. So it's just a text file. We've just examined it with the cat command. And every time you log in, right, you see this here every time you log in, because part of the login process is that the message of the day file will get displayed. And so if I just put an important notice here, hey, make sure and don't forget this or that or whatever, then you'll see it when you log in. And so there's a little file. There's another little common file that you're going to find on all Unix systems. I'm just looking for some short little text files. How about cat etc hosts? The host file, it's a real short one, just 2 lines long. And it has information about hosts. But way back in the day, the host file was really important. It was a really critical file because the host file stored the host name and the IP address, believe it or not, for every system on the internet. Every system on the internet was stored in this one file. And I remember when that was the case. So when I was your age and just learning Unix and so on, I remember the host file stored the host names and the domain name, and then the IP address for every system on the internet. And back in the earliest days, they didn't have any automated way to update that. So every once in a while, the sysadmin would just go to some authoritative server and download an updated version of the host file and copy it into place, and hey, there you go. And that worked kind of fine, you know, back in the old days when you had tens of thousands or maybe hundreds of thousands of systems on the internet. But, well, as the internet got more popular and so on, then that got too cumbersome, and they had to automate it and so on. So now instead of storing the IP address of every system on the internet, we have a service that is available to all of our systems that are accessing the internet, and that service can look up host names and then find and resolve that and find the corresponding IP address. Do y'all know what that service might be called? I bet y'all will recognize it when I mention it. A system that will map host names to IP addresses. It's the domain name server. DNS, a DNS server. And you know, when you're connecting up a new system to the internet and so on, you're setting up a new router and so on, part of your router configuration, if you were to log into your router from your home LAN and look at the config, there's going to be something about, hey, what's the IP address? How am I going to get to a DNS server so that I can resolve host names and so on? So routers and systems and so on need to be aware of DNS. And now it's a dynamic thing. It's a dynamic thing. And it's kind of a tree structure then also. If I wanted to buy, I don't know, some pair of chukka boots from Australia or something else like that, so I go to my favorite little boot salesman on the corner of Sydney, Australia, and I go to his store online. Well, do you think my PC happens to have that information, that IP address stored in its cache, if you will? No. So my PC is going to ask the DNS server, hey, do you know the IP address of Bob's Chukka Boot store in Sydney, Australia? And of course it's going to say, nope, never heard of it. And it's going to send a request up to the next level server. Hey, do you know what the IP address is for Bob's Boot store in Sydney, Australia? And the answer is going to come back, no, but eventually it's going to go up high enough until it gets to a server that says, yeah, I know the IP address of that server. And then it gets flushed down all the way back to my PC. And all of those DNS servers in between, they'll keep that information in cache. They'll keep it in memory. And then if I, an hour later make that same request, actually my PC itself will keep it in cache then also for a little bit, but so will the DNS servers then, so that it doesn't have to go up all the way up the chain and then all the way back again. So DNS kind of helps us out in this case. But the poor little host file, pity the poor little host file, because it used to be so important, and it would have hundreds of thousands of entries in there, all of the systems that were registered on the internet, and now it has just that. So localhost, what the heck is localhost? Well, if you do network programming, you can write programs so that a client can talk to a server. And a lot of times those are on different systems, right? So you have the internet in between, or you have a local network or the internet or whatever in between. But so imagine we've all, of course, have surfed the web, and some of y'all might have done a little bit of creating a web page. So if you create a web page, it sits on a web server. It sits on a web server. And if you're surfing the web, you're at a web client, if you will, running a web browser then, right? So normally you got the server on the internet, then you got your client, whether it's a tablet or a phone or a PC or whatever, then those are two different systems connected by a network. But what if you are developing a web page, and as a result, you are surfing that web page from the same system where the web page resides? So that can happen. That's the exception to the rule. But if you are a web developer, it might be the case you're sitting at a system surfing the web, and actually the web server that it's surfing is the exact same system you're sitting on. So it doesn't need to go out to the network, in other words. You can unplug from the network, and it should still work. How does that work? Well, because when you put that request on the network, the software is going to say, oh, well, as it turns out, that IP they're requesting is the same IP as is registered to this very system. So we're going to have you talk to the local host. We recognize that's the local host. So anyway, piece of trivia, 127.0.0.1 is the IP address that all systems use to talk to themselves. Kind of weird under those special circumstances. And now, poor little host file, that's all it has, is just it has definitions for what the local host IP address is. Kind of sad. All right, so there's that. And oh yes, so how I got to this is, check this out. I can say cat etc message of the day and etc hosts, because I told you over here the ... says we can put multiple files there, and it's going to pin the one to my screen, then it's going to pin to the other one to the end of that. And there we go. We see that, right? Here's the message of the day file, followed by the host file. Okay, so there you go. So there's the cat command. How are we doing on time? 9:30. We're doing okay. All right. So let's get into the meat and potatoes for today, I guess. We're gonna show you now how to copy and rename and relocate files. Okay, so far you've navigated a file system, so you've moved around the file system, you've kind of looked around and drawn pictures and so on, and so you have seen some files that existed, you know, in that user user data Unix directory, for instance. But you haven't done anything with them other than note that they were there and draw a picture of them, if you will, draw them on your picture. And we showed you today how you can cat files to display them. But what about copying files and relocating files and renaming files and those kind of things? We're going to do that today, give you another homework assignment, and then we're going to come back in the next class and we're going to show you how to create files from scratch and how to edit files. And that ends then, so our next class period will be the last one to end our introduction to the development environment, to Unix and Linux, and we'll start talking about programming then 2 lessons from today. All right, so let's start out with the copy command. We're going to go with that one first. Okay, so here we go again. We'll just mention it here again. I like to have one central location where I just list all of the commands, and then we'll give examples and details and so on down below. So once again, the old hippies from back in the day, they like to abbreviate things. A lot of times vowels will drop out and so on. Anyway, the copy command, just typed into the server as just CP. To copy a file, details, and video 3. All right, so let's go down to vid3 and see if I can come up. Whoa, what the heck? That's bizarre. I assume you guys saw the same thing. Part of my screen kind of disappeared, and then it came back. That was a little concerning. All right, usage for the copy command. All right, so it's going to look like copy, and then we're going to say source and destination. Okay, where source is a path to a file. So when I say a path, it could be either a relative path or a full path. You know, probably mentioned it last week or last lesson, but probably worth mentioning again. There's no command in all of Unix or Linux that require a full path or a relative path. It's just whichever one is convenient for you. So source is so this is something that you have to replace with a path to a file. All right, and the destination is a path to this is kind of weird, file or directory. So that might seem kind of confusing. Well, we'll show you examples of that. And the copy command can be a little tricky. So I think what I'm going to do is I'm going to mention that we're going to give you some simple examples of this, but I'm going to leave some of the, I don't know, more confusing examples off for today at least, and we kind of come back and show you more of those as we go. So I just want to show you the basics of the copy command. So, in fact, here, before we even get in, the most common way to use copy would be something like this: to number 1, CD to the desk directory, and then number 2, all right, is going to be to copy, and then full path to the source, and then for the destination, dot. All right, we'll let you get that typed in, then we'll show you examples of that. All right, so the most common way for us to use the old copy command, kind of 2 steps, if you will. Well, we'll show you another common way. to use the copy command then also. All right. So, again, right now, we're not showing you how to create any files from scratch. So all that you can do is just copy an existing file. Well, the good news is we've shown you 2 common files. We'll probably just pick the smallest of those, get a host file, just to not consume a lot of disk space. We have plenty. But anyway, we'll just use this little 2-line file here called the host file, and we'll make a copy of that. So if I wanted to copy the host file somewhere, well, I need to have permission to copy that file to that somewhere location. For instance, if I was to say copy the host file, and I'm going to use a full path here, etc hosts, and I'm going to copy that to the root directory. And the root directory, way up there at the top. Well, as it turns out, I don't have write permission to the root directory. So anyway, permission denied. So in other words, the destination, if you're going to copy a file somewhere, you have to have permission to create a file there. Yeah, anyway, you have to own that directory, or it could be a directory whose permissions are wide open. Oh yeah, there's one of those that we mentioned. Remember the temp directory? When we were drawing our picture of the common directories in the Unix file system up underneath the root. Again, we had bin and etc and home. Temp is world writable. Anybody can write there. So it's kind of a place that you can put files if you need temporarily. Used to, it was kind of a way to work around disk quotas and so on, which we're not running here right now. But anyway, so oops, I don't have permission here. So I need to cd to the destination directory. Well, I'll tell you what I'm going to do. I'm in my home directory. I'll just copy the host file here instead of to the root directory. So step number 1, done. You want to make sure that you have cd'd to the destination directory. I have done that. I'm in my home directory, and that's where I want to copy that file. So I'm going to say copy. Then I'm going to give a full path to the source, /etc/hosts. And then I need to specify a destination. And it shows us here that the destination can be either a file or a directory. It can be a file or a directory. And the easiest directory of all is this one right here, dot. So, we discovered dot was lurking in every single directory in the file system. We discovered that in the last video. And that's kind of cool. It allows us to go up one directory. So dot is useful for referring to the parent directory with a nice short relative path. Anyway, we kind of glossed over at that point, well, what about the dot directory? Well, we just saw that it existed, but we didn't discuss it until today. So the dot directory is a relative path to the current directory. See, because the thing is, if I leave off the dot and I just say copy the host file, which resides at /etc/host, and I don't specify the destination, looky here. Hey, so you thought I was making this up when I said, oh, we're going to call this the source and this the destination. See, check this out. I ran the copy command, and I didn't supply a destination. And then the copy command gave me an error message. Missing the destination. All right, so destination is not my term. It's the term that the system uses, source and destination. The source is what you're copying from. The destination is where you're copying it to. All right, so, oops, I forgot the destination. Hey, nice thing is, good with bash. All right, that was a question that was emailed in to me between last video and today about what exactly is bash? What exactly is bash? If we type W, the shorter version of that, and look at this. Well, gosh, you guys might not know a whole lot about bash, but it sure looks like an awful lot of you are running this program called bash. Over there on the right-hand side, it shows what program is this person running right now. And all of us right now are all running bash. So it is the program that's executing, and it's displaying this command prompt. This command prompt is nice and friendly. It tells me my username and then the server name, which is CS, and then plus the little tilde. It kind of gives me a little hint as to where I am in the file system. Oops, and then gives me the $sign and then a space. And now bash, this program, it displayed the little green prompt in my case, and now it's just sitting, waiting for me to type something in. And when I type something in and hit enter, it's going to read that command and it will execute that program, and then it comes back and asks me again. So it's the program that is prompting me, what do you want to do? And then it does it, it comes back and asks me again. So it's kind of my user interface to the system, if you will. All right. So, oh yes. So nice thing about bash is you can walk through previous commands by using the arrow keys. See, check this out. I just executed the W command. If I hit up arrow, hey, there's the W command. Up arrow again. Hey, there's that copy command that failed because the destination wasn't there. I'm going to hit up arrow, space, dot, and go ahead and edit that previous command. So you can use the arrow keys to walk through previous commands, and then use the arrow keys and the backspace key and so on to make changes to them and re-execute them again. So that's right, I forgot the destination. So now dot is the destination, and dot is the relative path to the current directory. Because you can't just leave it off. You know, the dot directory. Does this make any sense to type ls space dot? It works, but did the dot really add anything to the picture here? It didn't, because if I type ls by itself, it assumes, well, I guess he wants me to list the current directory, and he does just that. What about cd space dot? Did that really help me out here? That just says cd to the directory that you're already in. Well, so that's kind of a useless thing. So dot doesn't really make a lot of sense, except for, oh my goodness, it really comes into its own as the target, if you will, as the destination for a copy command. It works great. It works great. But if you want to use dot, well, in order for that to work, you need to cd to the destination directory, and then you can refer to the destination directory just with dot. So there you go. We have copied our first command, or excuse me, we've copied our first file. And so in fact, hey, looky here. It's already showed up. I copied it here. And looky here. It popped up. There's something called hosts in my home directory, in my current directory, ls-l. And I'll be dadgum, look at that. I've got a file called hosts. Sure enough, look over here to the far left-hand side, because it has a dash. It is a file. And anyway, that's the one that I just copied there. So ta-da! And, you know, hint, hint, hint. This will be, this little two-step process, this is the best way for you to copy a bunch of files that you have to copy on this lab that I'm going to assign at the end of class today. So do remember this here. But, so this is a very, very common way, and it works very well. Certainly this is the technique, these little two-step process over here, that I suggest that you use when you're completing the second half of that little file system lab that I'm going to assign at the end of class today. But, so in this case, all right, the destination, it has to be either a file or a directory. When we're using these two steps here, is the destination a file or a directory? Help me out. This is the destination, the dot, and dot is a directory, right? Okay. But it can also be a file. It can be a file too. Does that make any sense? Well, let's look here and see. Check this out. Copy. And now, instead of copying the host file, which is up and over, you know, I had to supply a full path through it up underneath the root and then in the etc directory, and then the host file resides there in the etc directory. Well, now I have a copy of it. And I can make a copy of the copy. Okay? So copy hosts, hosts to A. All right. So this was the source, just a relative path to the source. So last time we used a full path to the source. Well, if it's convenient, you can use a relative path. And if the file you want to make a copy of and where you want to make a copy of it to is the same location, then it just probably makes sense to just use a short little relative path here. So host, that was a relative path. That was this file here that's in my current directory. And then A, that's the destination. And ls-l, and would you look at that? Sure enough, now I have a file called A, which is 158 bytes, just like the host file is 158 bytes. We can cat A and see, sure enough, looks like the old host file there. So there's an example of I used the copy command, and I copied a file to a file. I copied a file to a file. And note that the destination was renamed then, if you will. So there you go. This is kind of an example of, working from the command line. You can actually accomplish a couple of steps, if you will, with just a single command. You know, think about Windows. You know, with any graphical interface, if you wanted to make a copy of a file, you know, do you like shortcuts, Control-C and Control-V versus right-click copy and right-click paste? I certainly do. I hate right-clicking and selecting and so on. So if you like shortcuts, you're probably going to like Unix because it has a bunch of them. But anyway, you would single-click the file, Control-C, Control-V, and it's going to pop up as copy of, and then you got to go type the new name and hit enter and so on. So it's kind of a number of steps. But from the old command line, you can make a copy of a file and rename it at the same darn time. Okay, so that's kind of cool. Let's just show you a couple of more examples, but again, do remember you guys, on the lab assignment, you're probably going to want to use these two steps here. CD to the destination, and then just have the destination be dot when you're using the copy command, and very likely needing to use a full path to the source because it'll be somewhere else in the file system. Just like it was right here. We CD'd to the our destination directory, we supplied a full path to the source, and the destination was just dot. But let's work a couple of more commands just for grins. How about copy, and I'm going to say, let's see here, etc hosts to, oh, you know what, let's do first, check this out. Make dir, my dir, ls minus l. Okay, so here today I have file A and directory mydir that I just now created, and we'll just make a couple things. And just what the heck, we've got time to do so. We're getting ready to take a break here before too long, but we're doing just fine on time. So just for the heck of it, I'm going to draw a little picture just to supplement. In our mind, we need this picture, and sometimes it can be helpful to actually draw it out. So I have a file called hosts. I have a file called A, and I have a directory called mydir, for instance. Okay, so there's that. And now, with that picture in mind, and in this case also, since it's on paper, it can be kind of helpful, let's just practice doing some things here. Now check this out. How about copy A to mydir? So let's think about it. So the source is A. We're wanting to make a copy of A. That's a relative path. Oh, that's okay, because I've got file A right here in my current directory, so that looks like it makes sense. Now the destination is something called mydir. Oh, yeah, that's right. I do have, a directory called mydir. So compare that with this. You know, here I didn't have anything in my directory called A. I didn't have anything in my current directory called A. So when we copied this file to something called A, well, there's no directory called A. So it made a copy of this file to a new file that was called A. So the A became the copy, and A was the name of the copy. But the tough thing, until you kind of get used to it, there's nothing that you can tell by looking at A to know whether it's a directory or not. So, well, I don't have anything called A, so I guess that needs to be the name of the copy once we make a copy of the host file. We'll make the copy and we'll call it A when we're done. On the other hand, mydir, now of course I made the directory name nice and friendly here. Mydir is a directory. We see that. So this is it looks very similar to what we did here, but because I have a directory called mydir, that means the destination is this directory called mydir. So it's going to copy this file to this directory, and the name will remain unchanged. Just like when we copied the host file to our current directory, the name remained unchanged. So let's hit enter here. No news is good news. It would complain if something went wrong. And anyway, CD to mydir, ls minus l. Hey, look at that. So I have file A just popped up inside of mydir as a result of this. So that was pretty straightforward. But I kind of gave you a crutch there. I kind of helped you out by calling it mydir. Let's give it a different name. We'll go through the same example here and see if this kind of clicks. I'm going to CD and hit enter to take me back to my home directory. Oh, let me update my picture. So here in mydir, now I have a copy called A. Okay, so let's do something kind of similar. How about make dir D? All right. So I need to update my picture. Okay. So, you know, I can go and type ls minus l, kind of verify that worked like we think. All right. So D, look over to the far left, because this D way over here, D is a directory. So I think my picture is correct. So, all right, so check this out, you guys. Copy A to B. So A is a file. What about B? Is B a file or a directory? Well, I don't have anything called B over there, do I? I got the directory listing right up above this command. And there's nothing over here. There's no directory called B. See, this is a relative path. So it's going to look for B in the current directory. Here's a listing of the current directory. There's nothing called B there. So B is not a directory. As a result, it's going to copy file A to a new file called B. All right. Because there was no directory called B, it made a copy file to file. All right, we're going to lure you into a false sense of security. Copy A to C. Well, okay, this C, that's a relative path. It's going to look for C in the current directory. I don't have anything here called C. So it's going to copy file A, and it's going to make a copy of it, and it's going to be called C. All right, so as a result of that, here we go. This is what we get. Okay, now comes my fast curveball here, the slider. All right, so everybody watch out. This is the tricky one. Copy A to D. Check this out. We copied A to B, and then we copied A to C, and then we copied A to D. And again, you can't tell by looking at this stuff. You can't tell by looking at this D. You know, there's no difference between the D and the C and the B. What is important, though, is, oh, it's going to look for D in the current directory. The current directory has a directory called D. So you can't tell by looking at this. You have to look at this. You have to look at the picture. I'm making a copy of this file, and if it made a copy called D, if it made a file called D, that would mean that this directory has a child called D over here and a child called D over here, which it can't have. Even if one's a directory and one's a file, even then, they're both children, if you will, of that current directory, of my home directory. It's not going to allow that to happen. So get that trash out of here. So no, we can't have two children of the same parent with the same name then. So it's not going to allow me to create a file D here because directory D got in the way. Directory D happened to be there, and it was in the way. So here we're copying a file to a file. Here we're copying a file to a file. I'm luring you into this sense of boredom and complacency here. But here we're copying a file to a directory. And we only know that by looking at the contents of our current directory where it's going to try to create D. So in other words, a file A is going to get copied over here to directory D. So we'll hit enter, CD to D, PWD to verify, LS minus L. Oh, there it is. There's file A that we just copied there in place. Okay. Does that kind of make sense? I'm going to say that we're pretty good shape then on our copy commands. You copy from a file to a file, from a file to a directory. And hey, tell you what, since I'm here just for grins, oh, here's the bonus round then. All right. How about, could this work? Copy. I got this file A here. Now you have to remember, anytime you're using relative paths, if you're using relative paths, you must know, where am I in the file system? What's my current directory? Now the truth is, they could have created Unix without relative paths, and you would just have to type full paths to everything. And it would work, it's just more typing. So they added relative paths just to kind of make life easy, depending on where you are and so on. But if you use a relative path, it's going to start the search for that thing in the current directory. You have to know what is your current directory and what's there and so on. So A, that's a relative path. And oh yes, okay, I just verified here. I'm in directory D underneath my home directory. So I'm here. And when I refer to something called A, oh, that's this file here. But now if I say copy A to dot dot, okay. So dot dot, we know in this case, it's funny. You couldn't tell by looking here, here, or here. You can't tell whether those are files or directories, except for by looking in the system and seeing what's there and so on. But dot dot, can I have a file called dot dot? No, because every directory has a directory called dot dot, and it can't contain a file called dot dot and a directory called dot dot. So no, dot dot, life is easy. We know that's a directory. It's the directory up above us. So what I would be doing here would be copying this file to the parent directory. And to be clear, if I hit enter, that would work. And it would clobber this file right here. So we mentioned this earlier, and you're not going to get any warning. You're not going to get any warning. It's going to overwrite the dang thing. So in fact, let's just do that very thing I'm going to go ahead and backspace it off here real quick. ls minus L, my home directory, for instance. Let's look at the modification time for A. All right. Copy A to dot dot. No warning, no nothing. And then ls minus L up above. And, oops, ls minus L up above. There we go. And, hey, there we go. So it changed from 944 to 956, which is right now. So anyway, so yeah, in this case here, when we executed this command here, we copied this file to the parent directory. There was already a file with that same name. We did not get asked for a confirmation. It just clobbered the darn thing. Okay. But what if I had instead done this? Okay, so here the destination is a directory, but what if I did this? What the heck is that going to do? I'm copying, so my current directory is here. My source is A, so I'm going to make a copy of this file. I'm going to copy it up one directory, so I'm going to copy it here to something called E. Now, if I had this, then it would copy it over here. Dot dot slash E would actually take me up and then back down again, believe it or not, you know. But I don't have a directory called E in my home directory. So E is going to be a file that the copy is going to be named. So here we're copying it up to the parent and we're renaming the copy all in one command. So we'll hit enter, ls minus L on the parent, and we should have file E pop up, which it did. Okay, does that kind of make sense? So now I have dink, file E here. Okay, hey, it's right at an hour that we've been here. So tell you what, let's do the following then. All right, I'm going to come over here, and we're going to have a couple of homeworks for today then. I'm going to say we're kind of done with the copy command. Now here's one thing to be clear. This is a programming class. It's not a how to use the Unix operating system class. So I'm not going to give you test questions where I describe these, you know, bizarre things. Okay, here's a picture of a little directory tree, and you are here, and you want to copy this to there, whatever, and you show me the right, you know, I'm not going to give you questions on copying files and those kind of things, okay? But you just need to be minimally competent where you can do very simple little things, and over time you'll get better, and that's all you really need. So if some of this stuff that we went over today, especially the weird last example with the dot dot and so on, if it seems a little weird, that's okay. You know, don't worry about it. Again, for the lab, in fact, for everything you do, you could always just stick to these little rules right here for all of your copy needs, and it would work just fine. And but so there can be no test questions on that, so don't worry about it too much. And so if it seems a little weird up front, it's kind of expected. Don't worry, it'll get easier with time. So that said, yeah, I think it would be a good time for any questions on the copy command. Not too big of a deal. Okay. Let's take a break. We'll come back 3 or 4 minutes, and we'll pick up and move on, cover one more command, and then give you a start on your second homework assignment then that will be due at the beginning of the next class period. Let's take a few minutes. Okay, we are back. We've made good time here at this point. So we have shown you how to make a copy of a file. And the interesting thing is you can rename it as you copy it, you know, if you want, kind of depending on the syntax that you put together. But what if you have an existing file and you just need to rename it? You just need to rename it. Well, I guess you could make a copy of it with the proper name and then remove the original one, but that's kind of awkward, kind of extra work. But speaking of that, so that I don't forget, since I thought of it right now, let's just go ahead and introduce a command to allow you to remove a file. So, we have this command to remove a directory. We're just going to butcher it up, just shorten it up just a little bit here. To remove a file, we're going to use just the rm command. Rm, to remove a file. And I hardly need to give syntax on the darn thing, but I guess just to be consistent, we will. vid3. And all right, so down here we go. All right, usage for And once again, RM, and then we're going to give a path to a file. We'll just say file path. It could be a relative path, a full path, whatever. And I'm going to go ahead and throw in the old ... which means you can remove multiple files at a time. And oh yes, this is something I started to say, and I don't know, I saw a squirrel or something, I guess, and I forgot right before the break, but I'm going to add in now, related to, I'm glad that I happened to think of this, removing. Let's go ahead and get this going here towards the bottom of our notes. Any other notes will kind of squeeze up above this, but homework for today. All right, how about clean up your home directory? You know, removing, in other words, get rid of all this trash over here that we created. Okay, so that'll be a good little exercise. It'll take you just a couple of minutes. So you'll use rmdir to remove directory D and directory mydir, and then just use the rm command to remove these files. And you know, once again, you'll have to empty out the directories before you can use the rmdir command. And I mentioned this earlier that there is a command that allows you to remove a directory and everything that's underneath it. And just as a hint, I'll mention this now, that actually the command that I generally use for that very purpose is actually rm. So I'm saying here that, well, for our purposes, we're going to use rm to remove a file, which is 100% accurate. You can, with the appropriate options, which I haven't shown you just yet, also use rm to remove a directory and all of its contents and so on. So we'll show you that later, but for us, for now, you can get along just fine on Unix for quite some time, just using rmdir to remove empty directories, use rm to remove files. That's going to be kind of good enough then for now. But you know, I guess I could put a star here. Tell you what, I'll do this. Star. I won't even bother to define the star, but that's my little disclaimer here that, well, actually, you can also use rm to remove a file, but we haven't gone there just yet. So if y'all want to go ahead and put that little blurb in there, that's kind of fine also then. But all right, so I'm going to wait to clean up my home directory until later, because I want y'all to kind of stumble through that process on your own instead of just copying me doing it right now then, okay? So make sure you get that done. And oh yes, oh, now that I think of it, don't do it just yet. Now that I think of that, go ahead and leave all of this here, because let's use it to practice renaming and relocating and so on, okay? So we've shown you how to copy a file, and you can rename it as you copy. Let's learn how we can rename a file and relocate a file then also. And in fact, we can rename a directory and relocate a directory also. So back to our notes then for our last command of today, but it's kind of the most powerful one. All right, so it is called the move command. To rename or relocate a file or directory. Wow. I don't think I've mentioned it just yet. Maybe I did in the last video. But one thing that's kind of weird about the Unix commands, again, there's lots of little two-letter commands and so on, you know, copy and remove and move and so on. Anyway, we often pronounce them as words. We refer to this, you know, you're really not going to hear me refer to the CP command, except for when you're complete newbies. I might do that just to remind you what command you're actually going to type in. But I would, you know, talking one Unix person to another, I would refer to this as the copy command and the remove command and the move command. So the interesting thing is sometimes with these very, very short, butchered up little command names, sometimes you go and pronounce them as words. But, you know, one obvious exception, and it's one thing you'll just need to kind of remember, is sometimes we have a shortened version of a word here, but we don't refer to it by the word. So ls is short for list. We can list the contents of a directory. But for whatever reason, the Unix and Linux people, they don't refer to it as the list command. They refer to it as the ls command. You pronounce letters versus pronounce a word that those letters are the shortened version of. And I'm sure that's probably kind of confusing. Oh, someone sent their pen along with this. Who lost their pen in the process? Was that you?
That's right.
Okay. And that looks like a nice little pen there, so got a hand up? Oh, okay. Okay. Well, since you got crutches, I guess I'll deliver it to you then. All right. Very good. So anyway, kind of weird, but just something to keep in mind. And it, again, just goes back to the old guys that created this, they all just kind of threw stuff in and they just picked up these habits and routines and so on. But in order to appear knowledgeable about Unix and Linux, you need to, use it correctly on the system is certainly very important, but another small detail then, I guess, is to pronounce the commands correctly, if you will. And then we would pronounce this as the ls command. And, here you go, here's another one. Now, sometimes I'll hear people refer to it as the change dir or the change dir command. But as often as not, I refer to this as the cd command. But these here, you pronounce them as words. The copy command, the remove command, and the move command. Kind of strange, but it kind of is what it is, and it will make you appear more knowledgeable, more experienced to use the right terminology when you're talking to people about these commands. All right, so the move command, it's the big one. It's the big one. Now, we've already seen, remember we saw examples earlier where I copied file A from directory D up a directory and copied it to file A, and it clobbered the old version that was there without warning. And so do be aware that you can make a mistake and have, quote, the system ate my homework kind of a thing to happen. You can clobber something and it's not going to give you any warning. And I remember making a few mistakes like that early on. And it's kind of funny now that, anyway, the move command is probably the most powerful of these commands that we've shown you today. And as a result, it's the most flexible. And it's also the easiest one to have something go haywire on you and perhaps have the system ate my homework kind of a thing occur. But anyway, what's kind of funny is I do remember when I was learning Unix and working from the command line, and every once in a while, dadgummit, it just didn't work right. Something is not working right. There's a problem with the system. This command didn't work right. The system didn't work right. And I'd get some unexpected results, and my inclination, which is probably common for people in general, would be to blame somebody other than myself, as I blame the system, And so I do remember a number of times, the darn system didn't work right. It is having problems. And I don't remember really appreciating this until later on. But looking back on it, I kind of recognized that as I gained experience, a funny thing happened, and the system started behaving better, all right? But I don't think I really saw the irony of that. I don't think I really recognized it kind of as it was happening. But looking back on it, I do remember that early on, I would have sworn that sometimes the system just doesn't work right. But later on, then all of a sudden it started working better. It wasn't that they were improving the system. It's just that I was learning to use it correctly. And boy, I'm going to tell you, my friends, as someone who's been working, with navigating the Unix system and so on, and working as a programmer for many, many, many years, I still do to this day. I still do contract programming and so on. And one piece of advice that I'd really like to pass on that would serve you well, don't make the same mistake that I have on a number of times, certainly like I just talked about, blaming the system. Whatever the system is, it might be hardware, it might be software, it might be compilers or editors or, any number of different things. But the system is this big shotgun term that just means everything. And there's been any number of times as a newbie where it's understandable to say the system isn't working right. But there's been times when I had more experience and I still thought, what the heck? What I'm doing here is perfectly fine and the system isn't doing it right. And then worse, if you think it, that's kind of okay. But take my advice on this, and when you recognize that the system isn't behaving right, keep your trap shut and don't mention it to anybody else. Because I've done that. I've done that with having some amount of experience, and I should have known better, where something just didn't make sense at all, and I uttered those foolish words, the system isn't working right. And then what can happen sometimes is later on you mention that to somebody, and then they come back the next day, hey, what about that problem you were working on? And the answer is always the same, never mind. In other words, it was my fault, and I discovered it a little later, So trust me, boy, these systems are reliable and stable, and they just do the same thing every time, and they behave correctly. And don't be like me and ever utter those words, especially, again, to somebody else. The system isn't working right. Recognize if you're getting an error message, if it just doesn't appear to be working right, the problem, almost guaranteed, is you, not, quote, the system. So you'll do better than I did in that regard. Okay, move. Well, we'll go ahead and put details down below here again. Oops, we're out to get that on. Details on vid3. The last command for today, then. We're doing just fine. We've got about an hour. We'll probably take a good chunk of that. All right. So I'm going to be lazy here, and I'm going to copy the usage for the copy command. So I'm going to highlight that and Control C and come down here and Control V. All right. So all of this is just a copy of this little paragraph up here, but I'm going to start making some changes to it. All right. So instead of CP, over here also. All right. Change that to MV, to move. And we come over here, change it to move. Where source is a path to a file, oh my goodness, or a directory, and dest is a path to a file or a directory. And in fact, I'm going to probably get rid of this most common usage thing and just leave it at that for now. So I'll take a breather here while y'all copy down or copy and paste like I did or whatever and get that going there. So the move command is a little more flexible than copy. With copy, for the most part, the source is going to be a file. You're going to copy a file. But with move, the source can be a file or a directory. And just like the copy command, the destination can be a file or a directory. All right. So I think the best thing to do is just to jump in and start giving some examples. Okay. So, and the other things to point out, there's no rename command. There's no rename command in Unix. There's no relocate command in Unix. To rename or relocate, or both at the same time, you use the move command. Okay? So it's very powerful, very flexible, and it's this command here which is most likely to make you utter the words, "The system is not behaving right, the system ate your homework." Now, to be clear, the system may do exactly what you told it and eat your homework, because, you know, that can happen also. So unfortunately, don't misunderstand my earlier statement about the system being right and it's not having an error. Don't mean that it can't eat your homework. If you give a botched syntax to any number of commands and the move's probably at the top of the list, then you can overwrite your homework and it be gone. So that can happen, and it's just because, oops, a syntax problem on your part. Okay, so very important for us to start messing around with these commands to have a picture of what's going on in the file system. And I'm just going to take a quick look here just for the heck of it. CD here, ls minus L. So I have hosts, and A, B, C, E are files. A, B, C, and E are files. D is a directory, and D contains something called A, and mydir also contains something called A. So I think my picture is correct. So now what we're going to do is I'm going to come over here, and I'll just switch color pins just for the heck of it, and we're just going to do some real easy things. All right, so just going to pick one of these random files here. How about this guy here? Let's rename him to capital A. And to be clear, Unix and Linux, they're case sensitive. So, to be clear, can I have a file called lowercase a and a file called uppercase A in the same directory? I can, because Unix is case sensitive. It understands lowercase a, uppercase A, two separate things, and so that's no problem. But anyway, just for a little exercise here. So I'm going to rename lowercase a to uppercase A. We're just going to give a number of examples. So for that, once again, for these commands, you can use full paths or relative paths or whatever. Hey, I think it'd be a good thing to CD to our home directory here. So pwd, oh yeah, I'm in the right spot here, and ls minus L. Sure enough, there's that bugger right there. I want to rename him. He's in my current directory. I'm going to rename him to capital A, also in my current directory. What could be simpler? So move A to uppercase A. So the source is what you're wanting to rename, and the destination is what you're wanting to rename it to. So that should work just fine. And one thing to observe, if I was to backspace this off and change MV to CP, then it's going to make a copy of the file, and the copy would get a new timestamp. It'd get a new timestamp. But check it out. When I rename a file, ls minus L, capital A, I'll just shorten the output here. Oh, that's kind of neat. So I renamed file A from lowercase to uppercase, and note that the modification time did not change because we just renamed it. We didn't modify the data, we modified the meta information about the file. We modified just the file name. All right, so there you go. So here's a nice little example. Again, kind of confusing. We're using the move command to rename a file. Okay, Well, just for the heck of it then, how about we do the following? We'll just follow that up with, okay. So we renamed lowercase a to uppercase a. And then I just flipped a coin here, and we'll just beat up on that same file again. Let's relocate him to my dir. Okay. All right. So sure enough, I'm still in my home directory, ls-l. Sure enough, there's good old file, capital A, right there. That all looks good. So how about move file A to my dir? All right. So here the source is a file, the destination is a directory. So this is a relocate command. So actually, when I'm going to say that move sounds like a good word to use there. You're moving something from one location to another. Renaming, not so much. Relocating, that's what we're doing here. Move sounds appropriate. So we're going to relocate uppercase a to my dir. And then when I look in my dir, it should have lowercase a. Here we go. Check it out. It should have lowercase a that existed previously plus uppercase a that we just relocated there. And in fact, ls-l in my current directory, uppercase A, it was right here, it is gone as a result of that. Piece of cake. So there you go. We renamed a file. We relocated a file. All right, the bonus round. All right, so I'm still in my home directory. Let's do the following. Let's take file B. We're going to relocate him to my dir and change its name. All in one command. So there you go again, you know, it's kind of, you can kind of recognize, you know, what would it take in Windows to do that? A Control-C and a Control-V and type in a new name change and so on along with it, you know. Actually, that's right, it would be a Control-X and a Control-V to delete and then, but actually, that's right, now that I think of that, I don't know if I've ever thought of this, kind of silly. So yeah, in Windows, wouldn't you do a delete and then a paste? But when you do that, does it update the modification time? I don't know if I've ever asked that question or looked to see for sure. When you delete and then paste, does it create a new file versus just relocating a file? I don't know. I guess you'd just drag and drop would be the other thing. You could just mouse press down, slide over, then let up. I think that would do a relocate. But then would it be a second click and a F2 or something like that then to rename then? But anyway, all in one command. Let's see if we can make that work. All right, oops, wrong one there. How about here? Okay. So I'm in my home directory, and we see here that, yep, I got this file B here, and I want to relocate him down to my dir. So move B to my dir, and then I want to give him the name capital B. So this is a path, if you will. This is a path to the new file. The new file is going to be a relative path. We're going to start searching for it in my dir, and then it's going to have the name B when we're done. So anyway, this will be the path to that thing after this command is finished. B doesn't exist yet, but it will after we complete this move command. So we'll hit enter here. Hey, no news is good news. ls-l on my dir. And sure enough, gosh, this modification time, that was 30 minutes ago, so you know the modification time did get changed. And file B, which we can see right here at 951, got relocated to directory my dir, and now it's been renamed uppercase B. Yeah, so there you go. Not too big of a deal. And you know, just for heck of it, we'll do one more, and then we'll call it quits, I guess. How about if just for heck of it, we'll cd to directory, then we'll just go to D. And can I rename and relocate a file going up? You know, I certainly could. Move. So look at my picture. I'm in directory D. In fact, I'll type pwd just to verify that. All right, and ls-l. There we go. I've got file A here. How about move A to ... Oops, to ... There we go. So that would move him up. Hey, the good news is there is no current file lowercase a there because of the rename I did earlier. So if I hit enter here, that would work. And then I'd have a file called lowercase a back in my home directory. But if I wanted, I could go ahead and give it a new name. New name, we'll just do that. All right. So I'm going to move file A up a directory and then give it a new name at the same time. All right. cd to my home directory, pwd, ls-l. Hey, there's a file called new name. Again, about 30 minutes ago on its modification time. So that is correct. Not too big of a deal. So we have beat the heck out of files with the move command. Let's just do a couple more just for grins, and we'll punt, I guess, then. How about the following? Okay, we'll draw a picture of this. I got a little bit behind. All right, this guy here moved up here. He disappeared here and popped up here. A new name, I think it was, if I remember right. Let's do a couple of operations on directories, and then we'll call it quits. How about, all right, I'm in my home directory. I have this subdirectory here called D. How about move D to uppercase D? So what did I accomplish there? Did I relocate D somewhere? That's right, Ruben. No, we did a rename. All right, we did a rename. So ls minus L. Hey, there's that bugger. So I've got directory uppercase D here. On the other hand, if I say move, so this kind of takes us back to what we were doing with the copy command earlier. What if I say move uppercase D to my dir? All right. Oh, well, really, we can leave it at that. That would relocate, if you will, directory D, where now it moves it underneath my dir. So that command would give us this. All right. This thing here moves over now where I have directory D there. And I could even rename it at the same time. So you can relocate and rename a directory at the same time. So if I said, /X, it would rename it to X. But we'll just do a relocate instead of a relocate and a rename at the same time. That should work fine. ls minus L on my dir. And now I should have a directory there called D, which I do. Uppercase D, excuse me. Oh, that's right. I had renamed it and didn't update my picture, it looks like. Move D to, is that right? Yeah, D was a directory under my home directory. I didn't update my picture here for some reason. Oops, that's bad on me. This was capital D, and this was capital D. So there you go. So yeah, once again, we've done a lot of monkeying around here. Now we're going to say, I think we're done. And just get this cleaned up then before the next class period. Questions on copy, move, anything else like that? All right. So, well, we've got, it's still 40 minutes or something. We'll try to get you out in maybe 30, about top of the hour. Let's go and introduce the second half of your assignment. So, all right, getting rid of all of that. Poof, it's gone. Come over here. So I'm going to catch up, well, just a tiny bit at least. So you guys all have a picture. You all have a picture of user data Unix. At the top, you have Unix. You can skip everything above that. And then underneath that, we had A, and then B, and then C. Underneath that, we had some stuff, and then more stuff. All right. So help me out here. Underneath A, is there a file here called F? Do I remember that right? No. What? Give me a file under A. G. Okay. And even just that, we might just leave that for now and just call that good. Okay. So you guys have, here, tell you what, so I can draw using this tool here a little neater. So you have a picture that looks like this. Okay. All right, so you've got that done, your little picture. And now here's the deal. So you don't have to draw all of this out, but we recognize that anyway, we have slash and home. And this is the little symbol that represents your home directory and my home directory and so on. Okay. So what you're going to do for the second half of this lab that will be graded at the beginning of class in the next class period that we meet is you're going to manually recreate everything that you discovered over here, kind of over in the other part of the file system. Ultimately, this is kind of sort of connected in, to this eventually. You have to go through user and then data and then to Unix. But anyway, so you discovered all of that stuff over here. And for all of these directories, you're going to recreate all of them somewhere under your home directory. And I'll show you where right now. Okay, so you guys should already have a directory called PF1. So you don't necessarily have to draw this in, but if you want, that's perfectly fine. So everybody has a directory called PF1 in your home directory. If you look, I see some students nodding up and down. And anyway, eventually you're going to have lab 1. We're just kind of talking here. This really isn't that important to the lab, and a lab 2, but it will make sense here in just a second. And ... Okay? So under your home directory, you have a PF1 directory, and eventually you'll have under your PF1 directory a lab 1 and a lab 2 and a lab 3 and a lab 4 and on and on and on. Well, I also teach a class on the Unix operating system, and they do all of their work in a directory called Unix. And underneath there, they're going to end up with not a lab 1 directory, because see, for that class that I teach on Unix, lab 1 is the one that you guys just completed today with a little picture. So there's nothing to do as far as creating subdirectories and so on. But anyway, eventually, those students that are taking that Unix class, well, they're going to do lab 1, which we've already assigned to you. They're going to do lab 2, which I'm assigning to you right now, and then they're going to do a bunch more labs. We're stopping kind of short, but anyway, they will eventually have lab 2, and then it will have a lab 3, and so on. Let's move this over just a skosh to give me a bit more room here. Boy, that's kind of sloppy. Let me neaten that up a hair. All right, lab 3. There we go. ... Okay. So if that kind of makes sense, that you guys have a PF1 directory, and it will eventually have a bunch of lab directories under it. And then my Unix students have a Unix directory, and eventually a bunch of labs under that. So what you're going to do is you're going to recreate all of this stuff underneath lab 2. So in other words, you're going to have a directory called Unix. That corresponds to this Unix right here. Underneath it, you're going to have a directory called A, and a directory called B, and a directory called C, and so on. Okay? So why do they go to the trouble of showing you all of this stuff here? Well, because without it, it's kind of confusing. Because the starting point where you're going to do your work over here in your directory tree is not in this Unix directory, but it's in this Unix directory here. All right? And anyway, it just kind of fits in with my Unix classes where they're going to have a lab 2 and a lab 3 and a lab 4. And I don't want to clutter up this directory with all of this stuff that's just specific to lab 2. So underneath your home directory, you're going to create a Unix, and then a lab 2, and then a Unix, and then all this other stuff that you see here. Does that kind of make sense? So it does seem kind of weird. Unix, lab 2, Unix. So, you could, just start right off. Now, I can't do that. I already have a lot of this stuff here, but so I'm not actually going to hit enter. I'm just going to pretend. So if you're in your home directory, you would say make dir Unix. No, I'm going to hit Control C because I already have a Unix directory there. But it aborted, but it kind of looks, looks like it worked. And then we could say make dir Unix / lab 2. And oh crap, I forgot to hit Control C. Sorry for that. All right, so that's going to create this directory. All right, and then make dir Unix lab 2 Unix. Control C, Control C. There we go. Okay, so that creates all the way down to here. And then, once you get that far, I'd probably recommend CD to Unix lab 2 Unix and kind of go from there. Okay, and then now that I'm in my Unix, so look here, type pwd, verify where you are. I'm under my home directory, Unix lab 2 Unix. Okay, that corresponds to this directory here. And then you would say make dir A. I'm going to hit Control C here again, just to do so because I already have this created here. And then so on, ... Okay, so that's kind of what you need to do. The permissions on this lab are already opened up. So let me pull it up on the web, and then we'll just talk you through a little bit more, and we'll let you go pretty darn quick then. Okay, so I'm going to backspace off that and go Unix lab 2. And there's not a whole lot to it here. All right, practice working with directories and subdirectories and files and so on. All right, so what you're going to do in your directory, tilde /Unix /lab 2 /Unix, just like we drew on a picture of, create all of the subdirectories that are found under user data Unix. All right, so user data Unix corresponds to, so user data Unix, that's this one right here, corresponds to this Unix directory here. Not this one up here, but this one down here. What else did the assignment say? All right, so step 1, create the directories. I would recommend go through and create all of the directories. That's going to take you 10 minutes. One of those things, once it clicks, it's really easy. Kind of like navigating the little directory tree that you've already done. Now we're going to kind of navigate, and then we're going to type in make dir every once in a while, and it's kind of the same thing. So part 1, create the directories. Then once you get the directory tree created, then part 2, copy the files. Okay. Now here's one thing to think about. So at the end of the day, you're going to have everything that you had in your picture. All of these directories and all of the files will be replicated over underneath your home directory. And again, you might be asking that question, you mean to tell me there's no command in Unix that can make a copy of a directory and everything? Of course there is, all right? But I'm an old systems programmer, and so I have temporarily disabled that, all right? So you're going to have to do it the old school way, the one directory at a time and the one file at a time. You know, get the practice. It's no big deal. Once this clicks, I think there's like 12 or 15 directories, about the same number of files, so it doesn't take too long, okay? It's not that, in fact, you know how many there are. You can look at your picture there, of course, so it's not that big of a deal. But, okay, here's the thing. We're going to grade this in class the next time we come back in class. I'm going to grade them. Does that mean I'm going to real quick type in everybody's username and go there and look around? And, you know, you can imagine how boring that would be. It'd take me the entire class period to grade them by hand. I'd get bored and all the rest. So just like everything else, the cool thing is for you to appreciate, and I'll show you the little program that'll do it, that one time I went to the trouble and I wrote a little program that's about a page long, or half a page long actually, and it's going to grade your labs like that, okay? And so I'm going to run that at the beginning of class, and it's going to grade everybody's lab, but it's real picky. It's real picky. So make sure you do a nice, thorough job. And, you know, to be clear, one thing I want to mention is, so for instance, you're going to need to copy this file G from directory A to right here. But to be clear, I don't need just any old file called G. It needs to be a copy of this darn thing right here. And in fact, I went to the trouble, which wasn't much, I went to a little bit of trouble in that program, and I made it verify that this file's contents are identical to this file. So you can't just copy any old file like we were doing earlier. We were copying files willy-nilly, you know. So you need to make sure and copy all of the files that are here to their corresponding location underneath your home directory, okay? Because my script will check everything. And also, if you have any extra junk, oops, I copied it to the wrong thing, well, I'll leave that one there and just copy another one. So clean up any mistakes you make. So on this lab, you're going to use, of course, CD and ls-l and pwd just like you did previously on the first lab, a bunch. And then you also do a bunch of make ders and then some copies. And then, if necessary, you can do some rm-ders or some rms or some moves to correct boo-boos, but with a little luck, you won't need those at all. And one other thing to kind of be clear, you can, and it might not be a bad idea, to log in twice. Oh, crap. Hey, once you type in a bad username, you're toast. You can't fix the username. It's just going to continue to ask you for passwords. So you got no option there other than close the window. Go away. So what you can do is the following. Let's try this again. And you can, for instance, all right, CD, user, data, Unix. All right, ls, pwd, just like you did before, ls minus l. All right, oops, ls minus l. Okay, and then over here, CD to home, CD to Unix, lab to Unix. And all right, so you can look and see what you have there. So you can kind of have your picture and you can be verifying as you go and so on. It wouldn't be a bad idea to have one window where you're navigating this part of the file system and another window where you are over here creating these subdirectories and so on. And you know, one thing, now you saw the job I did of grading your lab 1. I went around and looked real quick, and if you had the little long part down to the side going down to the dungeon, that told me you probably knew what you were doing, and I gave you a thumbs up. But I didn't necessarily look at every little detail. So for instance, if you try to copy a file from from the source location to your destination, and it says can't find the source, then maybe your picture's wrong or something like that. So that would be where it's helpful. As soon as that happens, well, I'm going to keep this window here with the error message that I got, and I know where I am here, and then I'm going to go over to the source area and kind of double check things and so on. So that would be a bad idea, especially if you have any problems. Okay. Questions on that? All right, my friends. So do at the beginning of class, the next class period then. And I think we're done. Oh, the one other thing I didn't do, I'll do real quick, and then we'll wrap it up. Let me steal this. Control C, and I'll paste it to our notes then also under the homework section. Where is that thing here? Oh, yeah, part number 2. I'll paste that in, and let me make it nice and big then also. Come on, there we go. Okay, so there's that. All right, you guys, that is it. And hey, look at that. We're actually almost 30. Hey, we're 30 minutes early. So there you go. That doesn't happen very often, but we'll appreciate it when it does, I guess. So we'll come back on next class period, and we're going to start talking about the text editor, show you how to edit files, and that's going to wrap up our intro to the Unix operating system. You guys have a good weekend. We'll see you then.